I'm going to go over the basics of how to verify trig identities. Now, the first thing is to know what in the world is a trig identity. Well, a trig identity is something that looks like this. Is when we have two trig functions, or a combination of trig functions, equal to each other. And basically what we're trying to do is verify that the left side is equal to the right side. Now, looking at this initially, it's a very intimidating task. It looks pretty complicated. This one's actually fairly straightforward, and after the first hint, you should be able to verify this one no problem. Now, in order to do this, you need to know quite a bit of information. There are many trig identities that we know are fact. I'm not going to go through the proof of them. Here is a brief example, or a formula sheet of all the trig identities. I'm going to pause right here so that way if you want to, you could pause the video and copy them down. The main ones to know are the Pythagorean identities, tangent and cotangent identities, and the reciprocal identities. So if you don't memorize any others, memorize these 11. So the first thing I'm going to show you, give you some hints. This video is only going to contain 3 hints on how to verify trig identities. The first hint is to rewrite each function in terms of sine and cosine. This is where the identities list, voila, will be very useful. Now, I worked these ones out yesterday in class. I'm going to pause right here, so that way you could pause the video, look through these problems, and work them out. But I'm going to go ahead and work out 2 other examples, so that way you can see what I'm talking about when I mean rewrite these functions in terms of sine and cosine. But what I'm going to do here, I'm just simplifying these expressions, trying to simplify them down as much as I humanly can, because then eventually this is going to turn into verifying. So, first things first, I'm taking a look. I have sine, cosine, secant, and cotangent. Using the first hint, I'm going to change the secant and the cotangent. So sine of x doesn't change, sine of x. Cosine x doesn't change, but I know that secant is 1 over cosine of x. And I know that cotangent of x is cosine x over sine of x. And this is just coming from those identities I showed earlier in the video. Now looking here, I have 1 over cosine. That means cosine is going to cancel out. I have 1 in the numerator, 1 in the denominator. If you think about this as cosine over 1, well, those cancel out. I also see that I can cancel out a sine. I have a sine in the numerator, sine in the denominator. So the only thing I'm left with in this particular case is cosine of x. So this expression, even though it looks very complicated, simply goes down to be cosine of x. And that's really it when you're simplifying. Let's try the next one. So here I've got cotangent times cosecant times tangent. Again, I have 4 things. Looks pretty complicated, but ultimately it won't be. So using my definitions from earlier, I know that cotangent, I'll make sure you use the right letter, or Greek letter, theta. So cotangent theta is cosine theta over sine theta times tangent sine theta over cosine theta times cosecant, which is 1 over sine theta, times tangent, again, sine theta over cosine theta. So I've broken this down into its parts. Now I'm going to see if there's anything I can cancel out. Well, I see right here, cosines cancel. I see sines cancel. I also see another set of sine cancel. So it looks like the only thing I'm left with is I'm left with a 1 in the numerator, and I'm left with a cosine theta in the denominator. Well, 1 over cosine theta, if I look back to my original definitions, that simplifies to be secant of theta. And so this expression, even though it looked very complicated in the beginning, simplifies to be secant of theta. Now, as I said before, the ultimate goal is to verify trig identities, meaning we're just showing that both sides are equal to each other. Now, the second hint is to start with the more complicated side of the identity. typically it's a lot easier to break something down and to cancel out rather than to add more in and make things more complicated. So for example, I'm going to verify this identity. I've got secant x times cotangent x equals cosecant x. So what I'm going to do is I'm going to start with the left side. Since there are more things over here, I'm going to try and break this down, cancel things out, and hopefully I get down to cosecant of x. So let's see, I'm going to go back to hint 1 on this. So I'm starting with the complicated side. I'm going to go and rewrite these in terms of sine and cosine. So I know that secant is the same as 1 over cosine x times cotangent, which is cosine x over sine of x. And ultimately we want to get it to be cosecant. So let's see, I've got cosines that can cancel. So what I get is I get 1 over sine of x equals cosecant of x. And what do you know? 1 over sine is the same thing as cosecant of x. So I have verified the trig identity. I have cosecant equal to cosecant. Now you don't just want to leave it like this step up here. Eventually you want to get down and say cosecant equals cosecant. We're showing that both sides are equivalent. You don't have to, but it's just proper. Let's try the next one. So I've got cosecant times tangent equals secant. Well, this looks very similar to our last problem. So again, I'm going to start with the left side because it's more complicated, and I'm going to break it down in terms of sine and cosine. So I know that cosecant is 1 over sine of x. Tangent is sine of x over cosine of x. I eventually want to show it's equal to secant. Don't forget to put your equals and so on. It's just like an equation. Leave the equals on the other side. And I see that, oh, sines cancel. So I have 1 over cosine of x equals to secant of x. We know this is true because of our identities, but I want to go ahead and take the step and say secant x equals secant of x, thus verifying the identity. Let's try one more that's not so similar. Let's take a look at something like this. I'm going to verify the identity. Here I've got sine times tangent plus cosine equal to secant. Now this one's going to be a little bit more complicated than our last one. Now, again, I want to start with the left side and try and simplify it down by canceling. So let's see. This is sine, this is cosine. I'm going to go ahead and rewrite this one, tangent, in terms of sine and cosine. So here I have sine x times sine x over cosine of x plus cosine of x. Okay, well, let's see. Oh, can't forget my secant. Let's see what I have here. I'm going to go ahead and multiply. Now, here's an interesting fact. Sine times sine is sine squared. It's just like doing x times x, except we put the squared right before the parentheses. So it's sine squared x over cosine x plus cosine x. Now here I'm trying to add a fraction, essentially with another fraction. Now, thinking back to fractions, in order to add them, you have to have common denominators. Well, in this case, my common denominator is going to be cosine. So what I'm going to do, I'll write this out to the side. Scoot over just a little bit. So I have sine squared x over cosine x plus cosine x over 1. What I'm going to do is I'm going to multiply top and bottom by cosine, which is perfectly legal. If you think of cosine over cosine, this is just 1. I can multiply anything by 1 and it preserves equality. That's called the multiplicative identity. So when I multiply here, I get sine squared x plus cosine squared x. Each of those are over cosine. Now, when we're adding fractions, remember the denominator does not change. So I'm just going to add the tops. I have sine squared x plus cosine squared x all over cosine equal to secant. Now, you could be thinking, we just made things way more complicated than they originally were. Well, that's not completely true. If we look at our trig identities, this is one of those identities I suggest memorizing. It's called the Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. Well, I have sine squared x plus cosine squared x. Using that identity, this top is 1. Even though it looks a little bit more complicated, it simplifies nicely. Now, like before, 1 over cosine, we know that is secant. So we have verified the identity. The last tip for today is if you see a squared function, try a Pythagorean identity. Now, if you don't remember the Pythagorean identities, again, right here, if you're not sure, you can pause the video, write them down. They're very helpful to memorize. And what I'm going to do is I'm going to use Pythagorean identities to verify, simplify these two expressions. Now, I know this is going to take a lot of room, so I'm going to zoom out here. And I'm going to do them on some blank paper because I know it's going to need some space. So, first one, I've got sine squared theta minus cotangent theta times tangent theta all over cotangent theta times sine theta. Now, before I go into using one of the Pythagorean identities, I'm going to rewrite this a little differently. So what I'm going to do is I'm going to start by rewriting it by separating the numerator from the denominator. Since I know a lot of these deal with fractions, I may eventually have to deal with fraction division. So I'm going to separate this to make it a little easier for myself to see that. Now, before I go on, I'm going to see, can I simplify cotangent times tangent? Hint, you can. So I'm going to do that first. So rewriting it, all in terms of sine and cosine, may be another helpful place to get going. So cosine theta over sine theta times sine theta over cosine theta divided by, I'm going to do the same thing for cotangent. Cosine theta over sine theta times sine theta. Now, in doing this, I see, okay, sines cancel, cosines cancel. So this side, this part, becomes sine squared theta minus 1 divided by, let's see, those cancel, divided by cosine theta. Now, looking at the hint, I see a squared function. So I'm going to look at my identities and see what I have to work with. So sine squared is part of sine squared plus cosine squared equals 1. But I have sine squared minus 1. Here's what I'm going to do. I'm going to do a little side work. And then I'll come back to the original problem. Here's what I know. I know that sine squared theta plus cosine squared theta equals 1. What I'm going to do is I'm actually going to isolate sine squared. So if I subtract cosine squared from both sides, what I get is I get sine squared theta is 1 minus cosine squared theta. Now, what I'm going to do is I'm actually going to do some substitution. If you verify trig identities, yes, I know there's something else you can do, but I'm not going to do that at this point, just for making this a little simple. I'm going to take this and replace sine squared with 1 minus cosine squared. So here's what I get. I get 1 minus cosine squared theta minus 1 divided by cosine theta. So let's see, 1 minus 1, that cancels. So I have negative cosine squared theta divided by cosine. Now, just like if I were going to do x squared divided by x, coming out to be just plain x, I'm going to do the same thing here. Cosine squared divided by cosine is negative cosine theta. So that very complicated statement up at the beginning simplifies just to be negative cosine theta. Let's do one more. Let's try this one. So here's what I've got. I've got secant theta times tangent squared theta plus secant theta Now, there are a few different ways to approach this. Personally, I would try and factor this. And I think that's the method I'm going to go with. Just kind of a precursor of a hint to come. See if you can factor. Now, just like if I were to have, let's see, something like this. X, y plus x. If I were to factor this, I could take an x out of both of these terms, and I would get x times y plus 1. I'm going to do the same thing here. Take out a secant from both of them. Secant theta times tangent squared theta plus 1. Now I have the plus 1 because, again, think if I go back to the distributive property. Secant times tangent squared is secant, tangent squared. Secant times 1 gives us that plus secant. Now looking here, I've got tangent squared theta plus 1. You could be wondering, why in the world did I factor in the first place? Well, here's why. If I look at my Pythagorean identities, I know that tangent squared plus 1 is secant squared. I can make a very easy substitution here. Because of this identity, I'm going to rewrite this as secant theta times secant squared of theta. I'm not completely simplified. Secant times secant squared, just like x times x squared is x cubed, this is secant cubed of theta. So those are the first 3 hints on how to verify trig identities. I'll post the other 2 later.